Hi friends, in this video we are going to discuss about commutation process. So tell me, what is commutation? Here actually commutation nothing but the reversal of current. This is important. The reversal of current by means of what's that? By means of two. One is the commutator segments and brushes is called commutation. Here reversal of what, sir? Reversal of current. What current, sir? Armature coil current. What is that? Armature coil current. So commutation is nothing but AC to DC, DC to AC. That is in general way of thinking. But actually what is commutation? The reversal of armature coil current by means of commutator segments and brushes. Is it? Sir, once show it. So I will show here. Just listen here carefully. For example, I am taking a armature coils like this. For example, I am taking armature coils which are connected to commutator segments. For example, this is first commutator segment, this is second commutator segment, and this is third commutator segment. I am taking like this. And again, this is the armature coils which are connected to commutator segments. Same, I am taking in different examples. For example, this is first commutator segment, second commutator segment, and third commutator segment. So is like this. This is the third commutator segment. For example, it is going on like this, and this is the fourth commutator segment. Of course, this is the fourth commutator segment, and second one next, third. I am taking here like this. Here also there are different commutator segments. For example, first commutator segment, second, third, and fourth, right? And next I am taking here the fourth one is this. This is the fourth, the first commutator segment, second, third, and fourth. First, second, third, and fourth. And next commutator segment, these are the I taken a 5 steps to easy analysis. 1, 2, 3, and 4. These are the 5 steps. How I am going to explain this commutation process? See here carefully. For example, first of all, my brush is connected to second commutator segment. My brush which is attached with the second commutator segment. But actually armature is rotating. When armature rotating, my commutator also rotating. When my commutator is moving forward, nothing but now after some time, this is my brush position. In this brush position, once observe here, 75% attached with the second segment and 25% attached with the third segment. And next, after some time, I observed that here 50% with the second and 50% with third. And after that, I observed that after some time, 75% with the third segment and 25% with the second segment. After that, I observed that 100% with the third segment. 100% completely. So see here, for example, the armature coil current in this is IA, and is this coil also IA? Actually, here the in contact of brush, that's why this armature current collected here, but there is no contact of brush here, that's why this armature current again came here, and IA 2IA collected by my brush. And observe carefully, you have to observe this coil current. Are you okay? And see here, here also, this is my armature coil current, and this is my armature coil current. When this coil is coming here, here we have a brush drop of brush attaching of 75%. That's why IA collected here. And here also we have a brush contact, but just a 25%. For example, if you take here 10 amperes of current, here 10 amperes of current, this 10 amperes came here and completely 20 amperes of current, that 20 amperes of current is collected by the brush. As usually, for example, here 10 amperes of current and here 10 amperes of current. In this, only some part of the current collected, for example, 5 amperes collected here, and remaining 5 amperes came here, 5 plus 10, 15 amperes collected, 5 plus 15, 20 amperes collected here. You have to observe this coil current. Where came to here, here 10 amperes of current, and here also 10 amperes of current flowing. Here 50% in contact, that's why 10 amperes collected here only. Here also 50% of contact, hence 10 amperes collected here. 10 plus 10, 20 collected by the brush, but what is the current in this coil? 0 amperes of current is collected or flowing in this armature coil. And then after came here, here the 10 amperes of current, and here also 10 amperes of current. Here only 25% of brush, hence 5 amperes collected here, and remaining 5 amperes came here. 5 plus 10, 15 collected here. That 20 amperes collected by our brush, which is the in 4th position. And what about in 5th position, the last position? See carefully. This is my coil. This is commutating coil. This is another coil. And these are the commutator segments like this. See here, 1, 2, 3, 4, of course. Where is my brush position? Completely in contact with 3rd segment. Here 10 amperes of current. There is no collection of current because there is no contact of brush. The 10 amperes came here, and here also 10 amperes. Because of 100% contact, 20 amperes collected here and 20 amperes collected my brush. So observe the commutating coil current. Here in this coil, the current is 10 amperes in this direction. After that 5 amperes in the same direction. After that 0 amperes. After that negative direction 5 amperes. Nothing but current reversal is going on. And then after 10 amperes in reverse direction. Nothing but this direction of 10 amperes is reversed. That is nothing but reversal of armature coil current. This process is done by the commutator segments and the brushes. This process is called commutation process. This is simply what? Commutation. Sir, what happens are here? Once observe here. See, for example, this is the graph we are going to draw. Normally in this coil, we have a 10 amperes of current. After some time, this goes to 5 amperes of current. After some time, this goes to from 10 amperes to 5 amperes, then after 0 amperes. This is 10 amperes, this is 5 amperes, this is 0 amperes. After that, minus 5 amperes. After that, again 10 amperes. This is minus 10 amperes. Reversal of current. For example, this is the coil current IC. This is the negative direction of coil of current minus IC. This is called commutation. This process is called commutation. The reversal of current. The time taken to reversal of current is called commutation time period. What is that? The time taken to reversal of current from IC to minus IC is called commutation time period. Or this is also defined as, how we can define this? The change of brush position from one commutator segment to adjacent commutator segments completely. When the brush position from second commutator to third commutator, then the IC is became minus IC. That's why the time taken to shifting of brush from one commutator segment to adjacent commutator segments is called commutation time period TC. This is called linear commutation. Why? This is called linear commutation. For example, if commutation takes place like this, this is called sinusoidal commutation. Linear commutation and sinusoidal commutation. For example, if commutation takes place like this, see here, already actually this is commutation time period, but here itself it reaches to the commutation. So this is called over commutation or accelerated commutation. Accelerated commutation or over commutation. And this, for example, the commutation is going like this. This is called, what is that? See here, the time taken to reversal of current is greater than the commutation period. Actually, commutation period is, for example, 1 second, but it takes 1.05 seconds. So here the commutation period is more. That's why this is called delayed commutation, or it is also called under commutation. Delayed commutation or under commutation. So generally this is delayed commutation. This is simply what is our commutation. Linear commutation, sinusoidal commutation, over commutation and under commutation or delayed commutation. But generally here the main cause or mainly the regularly occurring problem in the machine is delayed commutation. Now we have to study about delayed commutation. Right, before that, once calculate the current. We have a small formula for that coil current, that commutating coil current. The commutating coil current is equals to actual current of the, what is the brush position, A1 area of the first and area of the second by area of the first plus area of the second. For example, take here in this case, IC is equals to the actual current 10 amperes of area of the first one 100%, area of the second one 0, and area of the first one plus area of the second one, area gets cancelled, so IC is equal to 10 amperes. In this coil current 10 amperes. But here the coil current is equals to 10 of, what is area of the first one? Only 75%. And what is area of the second one? Only 25%. 75 minus 25 is nothing but 50. Nothing but only 1 by 2 upon 75 plus 25, nothing but 100, nothing but 1. 10 multiplied with 1 by 2, IC is nothing but 5 amperes. And what about here? IC is equals to 10 amperes into area of the first one 50% minus 50%. 50, 50, 0, 50, 50, 100, whatever, 0 into anything, 0 amperes in this coil. And see here, in this case, IC is equals to actually 10 amperes. What is area of the first contact? The first contact is 25%, second contact is 70%. So 25 minus 75 is the minus 50, and 25 plus 75 is the 100, nothing but minus 1 by 2. Minus 1 by 2 of 10, minus 5 amperes, in negative direction 5 amperes. And in this case, actually 10 amperes, Area of the first one is 0, area of the second one is 100%, and area of the first one is 0, area of the second one is 100%. Nothing but minus 1 into 10, minus 10 amperes, negative direction 10 amperes. So here the important one is the formula. If they may ask you question, what is the commutating current? I is equals to area of the first segment minus area of the second segment by area of the first segment plus area of the second segment. This is the formula. You have to remember if they may ask you a question on this. Whatever, this is the commutation. So I explained you what is commutation. Now here the problem with delayed commutation. Let's go for delayed commutation. What is delayed commutation? Right? So check the heading, delayed commutation. So tell me, sir, what is the definition of delayed commutation? The delayed commutation nothing but the time taken to reversal of current is greater than commutation period. This is the definition for delayed commutation. Or generally the commutation time period is less than time taken to reversal of current. Time taken to reversal of current greater than commutation period, or commutation period is less than time taken to reversal of current is called delayed commutation. Sir, what are the reasons for delayed commutation? Can you tell me? In that, the first one is armature reaction is the actual reason, and next one, improper joints again, improper joints between pole core and pole shoe, and pole core and yoke. This is also one of the reason. And next one, improper or uneven air gap between brushes and commutators. Brushes and commutators. These are the reasons for delayed commutation. In general reasons again. So other than this, the reasons for delayed commutation is very important one, reactance voltage. This is very important. The reactance voltage is also the main reason for delayed commutation. Sir, what is reactance voltage? Where it is induced? The reactance voltage which induced in the commutator segments during the commutation. During the process of commutation, when this is going on, at that condition, the EMF will induce in the commutator segments. That EMF is called reactance voltage, which damages the brushes due to delayed commutation or sparking commutation. So, can you tell me what is the value of reactance voltage? We know that generally V is equals to L into di by dt. This is the actual voltage. So tell me, the reactance voltage is equals to L into what is change? Change in current. The change in current is IC minus of minus IC, and the time is commutation period. So tell me what is the reactance voltage? VR is equals to L into 2IC by TC. This is the reactance voltage which is induced in the commutator segments, which is the main reason for delayed commutation or sparking commutation. Is it okay? Right? So up to now we discussed what is commutation, what is delayed commutation, what are the reasons for delayed commutation. Now remedies. How we can avoid this delayed commutation. Right? So let's see what are the remedies. Remedies are methods to avoid delayed commutation. That is the our point. So what are the methods are there to avoid our problem. This is our point. So in that, the first one, very normal thing, by using strong magnetic field, we can avoid this delayed commutation. Is the first thing, very simple thing. Nothing but in this case, we have to increase field number of turns. When field number of turns increases, the magnetic field increases, strong magnetic field. When the strong magnetic field is there, then the delayed commutation neglected, removed, avoided. This is the first one. And next, what is the second one? Second one, by placing rectangular holes on pole tips. By placing rectangular holes on pole tips. Actually, we have a pole tips, right? So by placing the rectangular holes on the pole tips, this is also another method to avoid the delayed commutation. Are you okay? And next one, very important. These two are the normal things actually. But next one, very important. Already you know, brush shifting method. What is that? By brush shifting method also, we can avoid this. This is also already you saw how we can improve the commutation by shifting the brushes. And these three are the normal things. Now the fourth one, by EMF commutation. Sir, what is this, sir? This is nothing but by using interpoles, we can avoid the delayed commutation. How, sir? Generally, the interpoles or compoles produces 120 to 130% of required flux. In that, 20 to 30% of flux used to nullify reactance voltage which induced in the commutator segments. That is the main reason, right? For delayed commutation. For that purpose, we are using interpoles. By using interpoles, the reactance voltage is nullified. If the reactance voltage is nullified, then what happens, sir? Then the delayed commutation is avoided or commutation improved. This is generally the thing which is used in our DC machines. This is the well preferable method to avoid the delayed commutation. Are you okay? Getting or not? This is the fourth one. And next, fifth one, by using high resistive brushes, we can avoid this delayed commutation. Sir, how it is possible by using high resistive brushes? For example, if you are using carbon or graphite high resistive brushes, then what is the time period of RL circuit? The time period of RL circuit is L by R. If the resistance of the brushes increased, then automatically time period decreases. This is used to avoid the delayed commutation. I already told you why we are using only carbon and graphite brushes. Because of high resistance, we can have a good commutation, nice commutation, improved commutation. That's why we are using high resistive brushes in our DC machine, right? So by using interpoles and by using high resistive brushes, and next by brush shifting method, and next by using strong magnetic field, and by using, what is that? Brush shifting and interpoles, and by using high resistive brushes, by placing the rectangular holes on the pole, by increasing the field number of turns, nothing but by using strong magnetic field, we can avoid this delayed commutation. So generally, this is the process how we can avoid the delayed commutation. These are the methods. Are you okay? Got it? So in commutation, we have only one formula. VR is equals to 2IC by TC into L. And another formula, commutating current is equals to I into, what is the formula? Area of first segment minus area of second segment upon area of first segment plus area of second segment. These are the things, and this is about commutation process. Is it clear? Thank you.